we can now go to the Descartes' rule of signs as one of the theorems that will help us find the roots of higher degree equations. When we say higher degree, higher than 2. So here, let us first, so that we could sort of, if for instance your equation says that there are no positive roots, then we should not try the positive values. Or if the equation say, the Descartes rule says there are no negative roots, then we will not try the negative values of these possible roots. So, but the Descartes rule of signs says that the possible number of positive roots is equal to the number of variations in signs. Variation in signs means from plus to minus, from minus to plus. Number of variations in signs of f of x or less by an even integer. So, let us now consider the signs of f of x. For f of x, you have, for the first, you have 2x cubed minus 3x squared minus 11x plus 6 equal to 0. We are just interested in the signs. So, what are the signs of f of x? Positive. Next term, negative. Next, negative, negative, positive. So, what are the variations in signs? This one. So, that is 1, 2. So, therefore, the possible number of positive roots is either 2 or 0. Either there are 2 roots or there are no roots. Now, so therefore, we still have to try the positive roots by trial and error when we consider the roots. Now, how about the possible number of negative roots? To find the possible number of negative roots, let us just change this. That is equal to the number of variations in signs of f of minus x. Meaning, you produce the equation replacing x by minus x. So, let us consider that f of minus x will be, replace x by minus x, that will be 2 minus x cubed minus 3 times minus x squared minus 11 times minus x plus 1. Okay. Now, f of minus x will therefore be, this is negative x raised to an odd power, therefore negative. So, negative 2x squared, 2x cubed. This is negative x raised to an even power, so it becomes positive. So, that will be minus 3x. So, this becomes plus. This is minus because that is odd power. Minus times minus, that will give you plus 11x plus 1. So, that is now but we are not really interested in the equation per se, but only in the signs. So, this is minus, so what is this one? This one. There. So, therefore, your equation will have exactly one negative root. So, if we summarize, possible number of positive roots is either what? 2 or 3. Negative roots, exactly 1. So, if we tabulate the possibilities of positive, negative, imaginary roots. Positive, negative would be real roots, then imaginary roots. You will have the following table. And we need the fundamental theorem of algebra. Which says that if the degree of an equation is n, then it will have exactly n roots. If an equation is of degree n, it will have exactly n roots. In our previous example here, we had what? We had, for instance, let's just give an example. Suppose that f of x equals, say, 5x to the 2,507 minus x to the power 7,000 plus 1. How do you get the degree of an expression? The degree of an expression is the degree of that term having the highest degree. Now, what are the possible degrees here? The degree of this is 2,507. Degree of this is 7,000. Of this, the degree of 1 is 0. Of course, it's a constant term. So what will be the degree of this equation? 7,000. So how many roots will this have? 7,000 roots, either positive, negative, or imaginary. This will have 7,000 roots. Now, going back to our problem, which is f of x equal to this one, 2x cubed minus 3x squared. This is of degree 3. So, the positive roots, these are the possibilities, negative roots, imaginary. Now, if there are two possibilities for positive is 2, if they're either 2 or, what did we say, 2 or 0? 2 or 0. Imaginary, negative roots is always 1. So you have 1, 1 here. Now, if you add 1 plus 2, that is equal to 3. What is the degree of our equation? 3. So therefore, what will be the possible number of imaginary roots for this combination? 0. There will be no imaginary roots. However, for this one, 0 plus 1, what do you get? 1. So how many imaginary roots? 2. Now, we have another theorem which says that imaginary roots occur in pairs. Imaginary roots occur in pairs. So therefore, you either have 0, 1, or 2. Let's try negative 2. So by synthetic division, what are the numbers again? 2. What's next? Negative 3. Next. Negative 11. Next. 6. So the possible root, these are all of the possible roots. Now let us try negative 2. Now, if by what we had, if the remainder is not 0, then it is not a root. So we just discard it. We try again. We try all over. So let's try minus 2. So, bring down 2. Minus 2 times 2, that will give you negative 4. Add minus 7. Minus 2 times minus 7, that gives you 14. So what will that be? Plus 3. Minus 2 times 3, that will give you minus 6. So that is 0. We know that there is only one negative root. So we are sure that this is a root. Now, this original equation is of degree 3. Now, this one, we already extracted x minus 2. So this is now depressed by 1 degree. So this is degree 2. So for degree 2, we can either use factoring or quadratic formula. So that will be 2x squared minus 7x plus 3. This is quadratic formula. You could use factoring, no? Because factors here are 1 and 2, 1 or 2. This one, 1 and 3. No other factors. And they must be negative because both negative. So, what combination? 2 and 1. No? So, that will be 2 and 1. So, 2x will be x. 2 will be combined with 3. So, 3 will be here, all negative, and 1. So, these are the roots. So, solving x minus 3 equal to 0 or x is equal to 3 is a root. So, if there is one positive root, there must be two positive roots according to our Descartes' rule of sign. And of course, if you have 2x minus 1 equal to 0, x is equal to 1/2. And indeed, you have two positive roots and one negative root. So this is the equation that, the possibility that came up.